when you actually think of data, there is operational data, there is information technology data, like the business side, the strategy side. Like in today's session, I'm going to talk from my experience how to bring that data together towards what value, right? Like, so what is that value that is hidden, and how do you actually capitalize on that data while it's still fresh? Okay. So close your eyes and think of if your company is running absolutely smooth, no data silos, everybody has their data flowing back and forth really well, and you don't have any blind spots, how would that actually look like, right? But how do you get there? Everybody wants like the no superhero required scenario in their data centers, but how do you actually get there, right? So integration of IT and OT. So when you really think of IT, it's driving your strategy. It's the data that's representative of your strategy, while OT is your operations. So if your operations are working not towards your strategic direction, which means like your OT data is not rolling up towards your IT data, there's a gap. There's waste. How do you alleviate that, right? So why is it hard? Like the curse of Babel is what actually comes to my mind, right? Like, so because people in suits and ties, they talk one language, and then the people that are on the floor actually getting stuff done, like they're talking an entirely different language. Like, how do you reference something in one IT and data model that actually maps to another data model that's completely referencing the same stuff but differently, right? Like, so for different outcomes. So you need to bring those things together. Like, how do you translate? So the consideration has to be homogenization of the language across your spectrum, and the homogenization of the data model. Obviously, you're going to have CRM systems, ERP systems. They're going to be having their own data models. Like, so you need a layer that's going to bring that data out and homogenize it and put it into a common storage, you said like data lake. So I look at data lake as a step 2 thing, because data lake is where you're storing the data. But before that, you have an opportunity to act on that data. So how do you actually determine what is that data, what is it telling me, and what is my intelligence that I'm going to apply towards that data and take actions? Because if you don't act on it, you are reconciling and dealing with the ramifications rather than actually preventing bad things from happening, right? So a lot of the times you guys are all in the industry, you probably know what OEE is, like overall equipment efficiency. That's a very neat construct, but then like you really need to look at like beyond equipment, like people, right? So people, process, and then comes the technology. So when you actually take this people, process, technology and integrate it together, now you have a process that you need to be monitoring and overall process efficiency. So translate from OEE into OPE, and suddenly you're at a different maturity level that you see your operations very differently, right? So one of the other use cases that we've been actually finding at Volt very useful is like, how do you detect a defect at the first instance? Not at the first batch, but at the first instance, because this can actually reduce your material waste, time waste, energy waste, personnel waste drastically. But everyone actually looks at QA sampling. How do you actually increase your sampling rate? You need like a high performance engine for that, right? So this is where, what are the foundational technology requirements that need to come together? You're looking at like a common data layer, as we spoke about, like homogenized common data layer. Once you bring it all together, how do you actually incorporate the streams of data that is coming from your sensors, video camera, frame data, and your change data from your IT systems? Like, bring all of those elements of data together to create a comprehensive picture. But because this data that's actually coming together can dynamically change, you want to have a system that's flexible enough to capture, grow, and evolve along with your data and requirements. So once you have all of that, real-time analytics. So this is a funny term because, like, for me, like the term real-time is interpreted based on the use case or the person that you're talking to. I've actually spoken to people and I asked them, like, what is your real-time analytics? And the lady said, we collect data for a week, and then we ask it really intelligent questions, and the answer comes like that. I'm like, that's fantastic, congratulations, right? Like, so the Real time is a relative thing. Like, it depends on your use case. Like, are you trying to just get answers fast, no matter how old the data is? Or are you actually trying to process the events as close to the event time so you can respond before conditions change, right? So this is where, like, in my mind, I always think, like, your data allows you to control your future as an enterprise. Only if you take advantage of it in the moment. If you don't, the future controls you, right? So what is the requirement? Obviously, this is a definition of Volt, if you really think of it, like a high-performance engine that can actually bring data from multiple sources together, apply intelligent rules to it, and along with the rules, incorporate machine learning model inferencing. I'm not talking about the generative AI LLM model that's a whole human-machine interfacing, while we're talking about machine-to-machine interfacing. So you need, like, your machine learning models that are continuously updated, retrained, be operational like that. So now, the second bit of the latency is the processing latency is one, but then also location latency is another, right? So, like, how do you move your intelligence to the edge? What do you need to look at in your systems to say what runs in the cloud, what runs at the edge, and be able to refactor that? That is the hardest part, to understand your business deep enough to be able to split it apart, deconstruct it, and then refactor it. Once you refactor it, you would be able to see that, like, there are specific KPIs that are going to benefit by moving intelligence to the edge. Don't move to the edge because it's a curious experiment, because then you're just going to say, like, I don't see any benefit in this, right? Like, so understand your processes well, so you know what KPIs are going to materially change, and the processes that measure into that KPI should be moved to the edge. Okay. The adjacent benefits, obviously, is reducing the cloud costs. Like, a lot of people primarily are sick and tired of surprise costs from the hyperscalers. Hyperscalers have a purpose, right? But when you actually have petabytes and exabytes of data that's actually getting generated, like, your sensors are moving from 1 kilohertz to 15 kilohertz, sample rates. Are you going to be sending all this data to the cloud? Like, what is your ingress and egress cost? Like, this is the surprise bill that you get. Like, it's like, holy smokes, like, I didn't expect this. Cloud is supposed to be economy of scale, right? How do you actually eliminate that surprise, like, move more intelligence to the edge? And not only that, like, there's a whole sustainability angle to this. There are two parts to the sustainability equation. One is actually your operations carbon footprint. The second is your technology and IT carbon footprint. If you're going to be generating exabytes and storing exabytes, out of which 95% of the data is system normal, this is a metric that you can actually take, right? Like, so 1 terabyte of SSD has 50 kilograms of CO2 at the creation of that SSD storage. So if you really look at CapEx and OpEx, what is your CO2 footprint as the CapEx for your storage? Why do you want to store all the data, right? Synthesize the data into intelligence, get rid of the data. You don't need the raw data. You don't remember how every single time that you caught a ball, you just know how to catch the ball, right? So you really have to think of it as get rid of the raw data, store intelligence, and create meta-intelligence out of that. Grow out of intelligence, not just our raw data. Not only this, everyone talks about AI-ready data, but you really need to start thinking the next level, AI boosting data, right? Because if your AI has to go through raw data, it's going to be taking time to index the data, process the data, derive intelligence. But if you can actually synthesize the data at the edge, and then use that intelligence for the next level meta-intelligence creation, you're suddenly at a higher maturity level, and you're pushing AI boosting data rather than just AI-ready data. Okay. So this brings us to AI, right? So everyone talks about generative AI. I'm not here to talk about that. Like, I'm talking about machine-to-machine communication and machine intelligence. So the areas of AI maturation that I'm interested in for the industry is agentic AI and physical AI. So what is agentic AI? It perceives environments, puts it into a context, and then takes intelligent actions towards predefined goals, and do this autonomously. Once you have the autonomousness built into it, Then you are actually doing the sense control feedback loop, which takes you to the next level, which is the physical AI, right? So perception, sensor data. Sensor data is now actually getting expanded into the context of vision data as well. Like, and vision data is expanding into time data, right? Like, so vision data, your video camera, you're looking at a frame of data, but don't just analyze what's in that frame. What led to that frame? What are the back frames that came into that frame, right? So now you're actually looking at the video feed over a period of time and making determination in a 4D model rather than just a 3D model. So then the reasoning part of it is where you have your standard operating procedures, you have your business rules, you have your machine learning model, put them all together and have intelligent inferencing to take action. What is the next best action to take? And this is the category of products you really want to think about, like so sensors and how do they actually communicate? How do you ingest the data? Once you ingest the data, what kind of a real-time data engine do you want to have? The 4 key capabilities we talked about, like which brings them together. Clearly, the choice I'm talking here is because Volt does that. And if you guys want, you can come to our booth and we can have a deeper discussion. Then the local AI agent, I just left it open because, depending on the use case and the base model and your training data, it could be any of the models that are out there, right? Like, so the AI agent itself is going to be synthesizing your SOP, the standard operating procedure documents, and trouble tickets, et cetera, from your individual organization, and coalesce that with your sensor data to make sense of it and recommend an action, and that action goes out to an actuator to take the actual action itself, right? So this whole journey needs to happen within milliseconds, and this is where, like, one of the reference architectures that I just wanted to, this is Volt's reference architecture that we've built with HiveMQ, a very close partner of ours, is what is that path going to look like, and what are the things that get done at each of these layers before an action is taken intelligently, not just by default. Okay. The integration points, as you can see, are ERP, CRM. These are all the IT systems that you bring in. The point is, don't de-silo the data just so you have one big store of data. De-silo the data because you want to take meaningful actions on that data, right? Where Volt helps is milliseconds. Like, our KPI, we are always measuring our latency in single-digit milliseconds. The reason this is important is the moment of significance is fleeting. If you do not address an event in that moment, the effect has already happened. Then you're just reconciling and dealing with the ramification. Think of what happened in the London airport, right? Like, so the substation heated up, it burned up, and the airport was out for 4 days or something like that. It was a completely preventable problem. All you needed to do was not just have sensor data, look at that data and make determination of what the next best action is in the moment. It could have been actually prevented, right? So work with us, and we'll work with you and see where we go. Come see us at stand 376, and we can talk more. But if you have any questions here, that is not too technically deep dive that we need to get into a rat hole, we can talk. So, all right. Thank you for the opportunity, guys.